Chapter 4 revision sides. I'm just going to go through everything from 4A all the way to 4I. I'll just do some examples as well, and then we'll just go from there. Just a disclaimer, you don't need to write everything that you see here on your reference sheet. Your reference sheet is double-sided, okay? One double-sided A4, handwritten. That's the most important thing, okay? And yeah, let's just go from there. Um, so your main units of length here. So you're gonna need to learn how to convert, and you also need to know like what these little abbreviations mean. Um, I'm pretty sure we've all dealt with this before. So you got kilometer, meter, centimeter, and millimeter. This flowchart here, very important. It just tells you how to convert between each of these units. So let's just quickly go do it. Convert these lengths to the unit shown in the bracket. So going from centimeters all the way to millimeters here. Just looking at my flowchart, I can see that I just have times 10. So I'm just going to go 35 times 10, and that equals to 350 millimeters. Next thing we got is we're going from kilometers to centimeters. So just looking at my flow chart here, yeah, I actually have to do two jumps. So I go from kilometers to meters and then meters to centimeters, just like that. So I got 120 here. What I'm going to do is I'm going to change this into meters first. So just times 1,000. And if you want to do it at the same time, you can just do the times 100 as well. So you're doing both steps at the same time. And then if you just figure this out, you can pretty much get your answer. So I'm just going to write something here. It's 5 zeros. So it'll be like 12 million centimeters. Now, if you wanted, I'm not sure if you have a calculator or not, but if you are given a calculator, you can just quickly type it up and it'll just give you your answer. So in this case, you got 123, yeah, 12 million to be precise. So perimeter is just a distance, okay? Now you need to make sure that all side lengths are the same. So what that means is if you're trying to find perimeter in centimeters, all the side lengths must be in centimeters and all that kind of stuff, okay? Sides with the same type of marking or dashes as we call them mean that they are the same length. So that means they are exactly this, like in terms of how long they are, they're the same thing. So for this one here, just find the perimeter of the shape here. Just notice how I got the dashes there. That means this line here is 4 centimeters. Now they don't really give you the measurements for all of the side lengths, but you can pretty much deduce it just from the shape itself. Maybe not blue, probably purple. Yeah, so basically we got at the bottom here 10 centimeters. I'm just gonna shade the ones in red. We may not know how long they are, but we know that they add up to be the same as 10 centimeters. Hence, we can say this whole thing, this whole line here above is 10 centimeters going across. Now, what's really important is over here, I've got 4 centimeters and another 4 centimeters here. So if we add them up, that actually becomes 8 centimeters. And if on the right side, the height is 8 centimeters, that means the height on the left side is also 8 centimeters. So now that we pretty much know how long each of the side legs are, we can just plug it into perimeter. So we can just go 10 plus 10 plus 8 plus 8. If you add them up, you get 36 centimeters, like so. Now, this is finding a side length given the perimeter. So basically, we know the perimeter already. We need to find a side length. That's it. So it's pretty much the opposite of what we just did last slide. But it's pretty straightforward. So we know P equals to something. So in this case, we have two x's because of these dashes. So we just go x plus 5. And then we can just substitute stuff in, simplify it. And we just need to find what this is. Find x. So how long is x? A lot of you would have noticed by now that if you just subtract 5 from 19, you end up with 14. And then you end up with the side length of 7 centimeters, like so. Next thing is circumference of a circle. The word circumference is just a fancy word for perimeter, and this only applies for circles. Now, one symbol that you'll see a lot is pi, okay? It's just a number that equals the circumference of any circle divided by its diameter. So basically that just means pi equals c divided by d, like so. Now, some other notations that you'll know from pi is these ones here, what numbers pi represents. So the short ones you'll know is 3.14 for sure. And you could do 3.1415, or you could do 22/7. Now these ones here are the main ones, okay? Features of a circle here, so you got the diameter. So it's a distance across the center of a circle. So as you can see in black, oh my days. So yeah, diameter is in black, and then you got the radius here. The radius is the distance from the center to the circle. And it's basically half the diameter, okay? So as you can see from my diagram, it's as clear as day. So the black line is the diameter, the red line is the radius. So something that you need to know is the circumference. The formula is C equals 2 pi r, or C equals pi d, okay? Just use, just a hint, okay? Use a formula according to what you have, according to what you're given. So if we just go through an example here, it'll just be a question saying find the circumference, correct to 2 decimal places. Now, just I also wanted to point out, I'm not sure. I'll double check calculator use. Double check calculator use. Okay. May not be available. May not be allowed. But I'll let you know more about it real soon. So in this case here, in my first circle, I got something that's 3.5 meters. Just based off my definition alone, I can see that this is actually the radius. So what I normally like to do is I like to write out what measurement I'm given. So r equals 3.5 meters. And we just need to apply this formula here, c equals 2 pi r. So c equals 2 pi r. Now, typically how I do it is I like to put brackets showing that, hey, I've replaced a letter with a number that I know. Now, if this test was done without a calculator, the numbers would be like something that you could work with. You could work with 3.5 as well, but You just got to remember 3.5 here, and you just multiply this by 2. You actually end up with 7 because you're just doubling 3.5. So 7 pi meters. So C equals 7 pi. If you were no calculator, so this is no calculator answer. If you were given a calculator, then obviously you'd type this in. So it would be 7 pi. Now, your calculator will sometimes end up with this. Just press the double arrow button to get the answer you need. So in this case, I've got 21.99. You've got to be careful because it says correct to 2 decimal places. So you have to round as well. So rounding is a skill that we've learned recently, earlier this term, if not earlier this year, but that's okay. We can always revisit it anyway. For my second circle here, okay, this is really annoying. I don't know what happened, but yeah, sure. I got a diameter of 4 centimeters. Just use the formula according to what I've been given. So because I'm given diameter, I will now use C equals pi d. And this is essentially just replacing like so. And I end up with 4 pi centimeters. So again, this is your no calc response. Leave it there because because the question's asking for 2 decimal places. We'll just figure that out real quick. 12.57. And there we go. Next thing is these units of measurement here. So it's area. Make sure you have these flowcharts down just in case. You never know if you need it. In this case, the flowchart here has 2 numbers, as you can notice. It just means whatever you see that's on the top, what's just underneath it is what the value is. Okay. Now, these aerial shapes, I'm not going to go through it because we should all have this sheet down. Just have a look here if you're missing any formulas. I recommend just writing them all down just in case you forget. Okay. Next thing is composite shapes. So they're just shapes by putting 2 or more simple shapes together. That's it. Now you can do it through 2 ways. You can add them or you can subtract them. So in this case, you just have to determine what works best and what's easier to deal with. Is adding the best option or is subtracting the best option here? It doesn't change the fact that you're finding the area of these simple shapes. So just to highlight here, I'm just gonna highlight all this stuff, this little gap. So this little gap here in yellow, that doesn't really exist. But if we were to fill it up, the whole shape that we would make is actually a rectangle, as you notice. So we know what the area of a rectangle is. It's just length times width. And in this case, it would be 10 times 6. So that's 60 meters squared. What I typically like to do is I just write the letter A and then I draw the shape as a subscript to indicate, oh, this is the area of the shape I'm looking for. Okay. Or you can write A and then the name of the shape. That's perfectly fine. But as long as your working out is clear, then you don't need to follow what I do. I'm just doing this because it works best for me. You can find out what works best for you. It's perfectly fine. Now, what's the shape in the yellow that I filled in that technically makes a triangle? So I'll just go a triangle, write down the formula for it, like so. Now the triangle's like typically upside down. So if we do something like that, if I rotate it, it'll look something more nicer to look at, and you can sort of figure out the base and the height of the triangle this way. But if you can spot it from the get-go, by all means spot it from the get-go. It's perfectly fine. So you have 10 times height of the triangle. So the height of the triangle is 4 divided by 2. This becomes 40 over 2, and 40 divided by 2 is just 20 meters squared. Key highlight here is make sure you put in your units. That's really, really important. Because we are removing the highlighted yellow part from the rectangle itself, what we're going to do is we're actually going to subtract. So A total equals 60 minus 20, and that ends up being 40 meters squared. Now, apologies, but I did want to go back to this. I forgot to add this in earlier. But when it comes to the flowchart, you have to be careful of a couple of things, okay? I'll just show you an example, like, to see how it's done. So I'm going from meters squared to centimeters squared. If you just look at your flowchart here, it says times 100 squared. Now, what you're supposed to do is you write 2.48 times 100 squared, okay? You do this. You don't square the first number. Don't square the question number. A lot of people make this mistake here. So you see how I didn't square this? If you squared it, then you would be completely wrong, okay? Never do that. Make sure it's just the number itself, and then the only thing that gets squared is the 1,000, 100, or the 10, depending on which conversion that you're working on. So 100 squared would be 10,000, so it would be 0.248 times 10,000. And then if you were given no calculator, you'd have to figure that out by hand. Now, just look at how many zeros there are, move the decimal point according to how many zeros there are towards the right. Okay, so in this case there's 4, so you just go 1, 2, 3, 4, stops there. So you just fill in the empty gap with a 0 here. So 2,480 centimeters squared, like so. For the next one, I've got 3,100 divided by 10 squared. This becomes 3,100 divided by 100 here. And then this just turns into 31 centimeters squared. Okay. So whenever you're dividing, you move towards the left according to how many zeros there are. If you are given a calculator, you can just type this first section in, and you'd pretty much get your answer. And let's go back to here. So with this shape here, for composite shapes, I can actually do one of two things. I can fill this out to make a rectangle, and then just like the technique before, I'd fill in something, I'd fill in the missing spot, find the area of that, and subtract. But sometimes you can just add as well, so it's up to you to decide which one's better. In this case here, I actually prefer to separate it like this, like so. The reason why I've done that is because you see these two dashes here. If you got dashes like this is technically now a square. So it actually makes my life easier. So area of square, so I'll just write SQUARE equals L times L, which is just 3 times 3, and that equals to 9 millimeters squared. That's done. Now, over here in my little box right there, it's colored in red. This is actually a rectangle, okay? So this is a rectangle, a rectangle equals length times width. And the reason why it's a rectangle is because the length and the width are different sizes. So you can just go 1.2 times 1. That's the same thing as 1.2 millimeters squared, like so. And now what you can do is just add these two together. A total equals 9 plus 1.2 equals 10.2 millimeters squared. Area of a circle, this is the formula here. A equals pi r squared. Now, if you were given a calculator, the square button is actually the button highlighted in red. So make sure we don't forget. Um, Now, this is more for the extension, okay? I did talk about it briefly in class, but this sort of follows more the extension, people. So if you were asked to find the radius given the area, this is how you would do it, okay? So it's just the square root of a divided by pi. Now, in order to get the square root button, you need to press the second button and then press the square button again. As you can see just above, just there highlighted in yellow, that symbol there is the square root. And to get that symbol of square root there, you got to do those two things. Now, area of semicircle, so, or half circle, you can pretty much, there's like two ways to think about it. Just half a circle, or you first find the area of a full circle and then you divide it by 2. Same thing as quadrant, aka quarter circle here, so no problems at all. So let's just go through one sample here. So it says find the area, correct to 2 decimal points. So a equals pi r squared because that's our formula. But first let's determine what our radius is. So our radius is 2 centimeters. So that makes our life a bit easy. So this becomes pi 2 squared. Now 2 squared is just 4, so your answer actually becomes a equals 4 pi centimeters squared. This is if you're given no calculator. Okay, if you want to play like this, then yeah, no calc. But if you are given a calculator, then you just go 4 pi, 12.57 again. Like so. Now this is more for the extension, okay? So the area is 40 meters squared, but you don't know the radius. Find the radius, so let's go based off the formula. R equals square root a over pi. You substitute a in, so 40 over pi, like so. This is more a calculator question. So if you type this in exactly like so, second square root, so 40 over pi, enter 3.57. So that means your radius is 3.57 meters. Let's just quickly go through this. So this is a quarter circle. So this becomes pi r squared divided by 4. So first off, my radius is 3 in this case. So pi 3 squared over 4. If you were given no calculator, this would be your final answer. because we are, so if you are given a calculator, then you just type this in. So 9 pi over 4, 7.07. That's it. Becomes A equals pi r squared over 2. And you got to be careful here. This 5 kilometers here actually represents the whole way. So in this case here, what we're actually given is the diameter. Now, step that you'll need to take is, because our formula requires radius, in order to find radius, you need to do diameter divided by 2. So that would be 5 over 2 in this case. This is the same thing as 2.5. So now that we know what our radius is, we can just go pi. Let's just try this without the calc first. Let's just try it out, okay? So it ends up with something like this. You actually get 25 pi over 4. And then this goes to over 2. Now, if you remember your fractions, this technically just means this right here. And if you apply KCF, so keep the first fraction the same, change the divide to a times, and flip the second one. So you actually end up with 25 pi over 8 kilometers squared. So this is no calculator. If you are given with a calculator, just type in 25 pi over 8, 9.82. Alright, we're halfway there. Alright, next thing is a sector. A sector is a part of a circle made by 2 radii and the curved edge between them. So the curved edge is this part here. But you can think of it like it's just a fraction of a circle, or you can think of it like a pizza slice. That's it. Now, only 2 things you need: the interior angle and the radius. That's how you're going to find the area of a sector. This is the formula that you need. So angle over 360 times pi r squared. Let's just go through some examples now. So I just go capital A equals A over 360 times pi r squared. I know that my radius is 2 centimeters here. So this becomes 120 over 360 times pi 2 squared. Now, if you remember your fractions here, you can actually simplify 120 over 360 to become 1/3 times 4 pi. And this essentially becomes 4 pi over 3 centimeters squared if you are given no calculator, like so. If you were given a calculator, then this would just become 4 pi over, whoops, 4.19. For this one here, you got a bigger circle, but what you need to notice is this 70 degrees is for the outside. So this is the angle outside. We need angle inside. So to do that, we're just going to take 360 and minus it by the angle on the outside. So we have 290 degrees. And we have our radius as well, which is just 5 meters. So we know radius is 5 meters. Angle here is 290 degrees. So you just go A equals 2. I'll just write it as the letter A here. So just write down the formula first. And now you can substitute stuff in. So 290 over 360 times pi 5 squared. This can become 29 over 36 times 25 pi. Now, if you were doing this without a calculator, you'd actually need to find what 29 times 25 is. So if I do that real quickly, 725. So it becomes 725 pi over 36. Now, I don't think you can simplify this. So, yeah, no, that doesn't work. So just leave it like this, meters squared. So this is a no calc answer. And if you were given a calc, then you just obviously type it in. 725 pi over 63.27. Alright, so now you gotta find area of composite shapes with like these weird sectors now. So remember, anything inside the blue is our actual shape. I'm just gonna highlight this to say, hey, we're just gonna fill this in order to make a simple shape that we want, which is a rectangle, as you can see. So we'll just go a rectangle equals length times width. The length of it is 20, the width of it is 10, that becomes 200 millimeters squared. Next thing you gotta do is find the area of the quarter circle. Now, the formula that I gave you to find the quarter circle was pi r squared over 4. Now, the problem is we need the radius of this circle, but it's actually quite easy to spot because you don't know what this side length is, but for this side length here, we do know. We know. And if you just look towards the left of the rectangle, you can see that this is 10 millimeters. So that means the radius is actually 10 millimeters. So that makes our life easy. Then comes pi 10 squared over 4. This actually becomes 100 pi over 4. And if you simplify this, it actually becomes 25 pi. Now, if you were to write this towards the end, that means a total is actually 200 minus 25 pi. No calculator. This would be your answer. But if we are given a calculator, you would do 200 minus 25 pi and you just find it out. So 121.46 millimeters squared. Next thing is prisms. So some key features that you'll see in the prism is that they have two identical bases. They have flat sides, okay, mainly consisting of rectangles. And the most important thing is they have the same cross section all along its length. So what's a cross section again? So cross section is the shape you get when you cut straight through a 3D object. If you have a look at this diagram here, this cube, if I were to make a cut, the inside shape of it is a square and it's very consistent. If I cut it in any orientation and around the whole object. So if you have a look here, if I were to make a cut like so, the inside of it would look like a rectangle, okay? And even if I cut it here, it'd be the same. Cut it here, it'd be the same. It'd make the same exact shape. If I cut it, say here, like that, the shape that it actually makes in the back is a rectangle as well. See? Just like so. Now, let's just talk over some things before we move on. So, this shape here would be called a rectangular prism, just because every time I cut this shape here, the cross section is always a rectangle. So we're just going to go through this where it's you got the length, got the width, and you got the height of it. I am just going to draw some stuff in here to make it a bit easier to see. I hope this will help to see the inside of the shape. So give me one moment. Alright, so I know I got this picture of a box here, but I've tried drawing as best I can so that you can sort of see through it, and this will help when it comes to trying to find whatever it is that I plan on teaching you next. So this will be very important. It is the total surface area. So the total surface area is when you add up all the areas in the faces. So if you have a look from a cube point of view, if you remember my tissue box example, you got something here, you got something here, you got something on top. But what you're also missing is the stuff on the side here, one on the bottom as well, and the one in the back. So that's why these diagrams are like super useful right now. They pretty much just like show you the see-through world, okay? So basically, a cube is pretty obvious. You're just finding the area of a square, so it's L times L, just like so. And you're just doing that for all the faces. And now there's 6 faces of the square. So that's why the TSA equals 6L squared here. For a rectangular prism, it is very similar in a way here. So you got the 2 rectangles in the front and the back. Those are the same things. So that's what we call the 2LH. You got the rectangles on the side, which is W times H. There's 2 of them. And then finally you got the top, and then you got the bottom here. That's your length times width there. So these formulas are really important. Now when it comes to like these odd shapes, you can't really do much about it. You just have to find the area of every single thing. And this is going to be a pain to do. So you're going to spend a lot of time working on this. Let's just find the area of the triangle. So that just equals to base times height divided by 2. Now because there's 2 of these triangles, you can just multiply the whole thing by 2 like so. So you actually end up with 6 times 8 divided by 2 times 2. If you did this properly, you'll end up with 48 centimeters squared. So those 2 triangles are done. Next thing you got rectangle. Rectangle back, which is essentially this right here, the one covered in red. You just gotta go length times width. That equals to 15 times 8. That equals to 120. Make sure you're putting in the correct units at the end as well. Next, you've got a rectangle side. So that's the slanted area here, which I'm just shading in now. So that becomes length times width, which equals to 15 times 10. And that is 150 centimeters squared, like so. And then finally, you got a rectangle bottom equals length times width. That is 15 times 6 equals to 90. Next thing you gotta do is you just add it all up. So you got 48 plus 120 plus 150 plus 90. This ends up making 408, I believe. 168,318, 408. Yeah, so it becomes 408 centimeters squared, like so. Home stretch. This is some new stuff. You'll be doing this in year 9 anyway, but it doesn't hurt to sort of learn it now. It's pretty much the same vibe as the other 2 flowcharts that you drew. The main difference is you got a 3. So this is specifically for volume, okay? Specifically volume. Just like so. Alright, the next flowchart we're going to do is capacity. So capacity is just the volume of liquid or gas in a container. These are the main metric units here. What you need to watch out for is watch out for milliliters and megaliters. The main reason why is the letter M. So milliliters is the one in this lowercase m, whereas megaliters is the one in capital M. This flowchart is relatively easy to remember because everything is just by 1,000 only. Alright, some special conversions between the volume to capacity. So typically what would happen is you're asked to find the volume of an object and then you need to convert that into capacity. Okay, so these are important. So 1 milliliter is the same as 1 centimeter cube, and 1 kiloliter, which is technically 1,000 liters, and that is equal to 1 meter cube. Formula to find rectangular prism is this: length times width times height. Volume of cube is length times length times length. Now, just to show you real quick, this is a very straightforward application. So you just go 6 times 4 times 2. Doesn't really matter what order you put it in because you are multiplying it. And this becomes 48 meters cube. So remember, volume is cube. Now, this is an example of finding the capacity. So find the capacity in liters of a container that is a rectangular prism, 20 centimeters long, 15 centimeters wide, 18 centimeters high. So just apply a formula for volume first. So we got 25 times 15 times 18. I'm pretty sure the numbers will be a lot nicer, but I can't be bothered, so let's just use the calculator. Times, what is it? Times 15. 6, 7, 50. 25, 6, 7, 50. 50 centimeters cube. Now we need to convert this from volume into capacity. So 6,750 mils. Now, because the question's asking to find the answer in liters, you just go 6,750 divided by 1,000. So your final answer is 6.75 liters. Alright, so how to generically find the volume of a prism? It's very straightforward. There's a formula here. So you got area of cross section times height. So as you can see, the cross section is the letter A. So this is your cross section. And then the height of the prism itself. Find the volume of these prisms here. Very straightforward. They've given us the area of already. So we can just go 10 times 3. That equals to 30 centimeters squared. For this one here, I need to find the area of the cross section. In this case, the area is a triangle. So base times height divided by 2. 4 times 2 divided by 2, that is equals to 4 meters squared. That means V equals AH. 4 times 8 equals 32 meters cubed, just like that. Now, volume of a cylinder, just some key notes. A cylinder is not actually considered a prism. The main reason why is because the sides are not parallelogram, so there are no rectangles, squares, or that kind of stuff there. Ideally rectangles, but you can find the volume of a cylinder because the cross section is just the area of a circle. So this is the formula here. Okay, and let's just apply it. So V equals pi r squared h. So they say round to 2, but I'll just show you both anyway. So we know the radius is 2 centimeters and the height is 10 centimeters here. So V equals pi 2 squared bracket 10 like so. This becomes 40 pi centimeters cubed. So this answer here is no calc. If we're given calc, then you would just type this in your calculator. 125.66 centimeters cubed. Remember to do that. And finally, this is just another question here. This is actually your diameter. So you got to convert from diameter to radius, d divided by 2. So 14 over 2 equals to 7 meters. That's your radius. So V equals pi r squared h, given that r equals 7 and h equals 20. This becomes pi 7 squared times by 20 here. Now, if you're given a calculator, you just figure this out. It's quite straightforward, but it's 980. Just because 50 times 20 is 1000, And so that should mean 49 times 20 is just 20 less from 1,000. So you would subtract it. You end up with 980 pi meters cubed. This is your no calc answer. And then if you are given a calculator, you just type this in. 3078.76 meters cubed. There we go. Nice and simple. So that's the end of everything. I know it was long, but I just wanted to double check and go through most things. So just remember to make sure you write your units in as well. Put that in the disclaimer. Put in correct units. Okay. Enjoy the rest of your long weekend. Okay. Take care.